Hello, we're now going to look at big data, which is a really popular area of computer science at the moment. There are entire university degrees looking at this area. We're just going to touch the surface a little bit today. So far we've talked about how modern businesses are able to collect and utilize large amounts of data. We'll continue looking at this in the next video as well. So there's loads of data available for businesses to utilize. And a new term for you, dataset. So a dataset is an organized collection of related data. By organized, I mean usually it's stored in a database, which is a really structured way of organizing data. And it's related, right? So a dataset is not a combination of loads of different types of data. It's usually one set of similar data, so with common characteristics. Maybe it's all the salary details for a company. Maybe it's all the likes on a particular YouTube video. Just some data which is related. So I define dataset because it's in the definition for big data. So big data constitutes datasets which are so large or complex that traditional data processing software cannot deal with them. So the term big data sounds like quite a childish term, and it really is related to large amounts, hence the word big, large amounts of data. And they're so large that with normal software, so normal everyday software, we cannot really manage them particularly. Maybe you try and open a big data set and your computer crashes. Maybe you can't even store it on normal storage devices. Maybe you have to use a cloud platform. So we cannot deal with it normally. And so it requires extra consideration. And by big, usually we are talking in the order of petabytes, which is the next unit up above terabytes. So a hard disk is usually a couple of terabytes, if not a bit less. And so a petabyte is 1000 terabytes. And then it may even nowadays be exabytes, which are 1000 petabytes. So we're talking a lot of data in big data, right? Big is a slight understatement, really. It's not only about volume, the amount of data, also the complexity is relevant. So by complex, usually that's regarding the data types. So maybe you've got some data which is a mix of different data types. So maybe you've got one column which is integers, maybe you've got another column which is text, and so analysing it's going to be a little bit more complicated. Also, you may have a column where you haven't got a normal data type. Maybe you've got no data type, maybe someone hasn't gone and labelled it yet, and so you are going to find it hard to process it without a data type being assigned. Right, to give an example, so far we've talked about how a loyalty scheme can be used by shops to collect data about customers and what they are buying. So maybe you are at a supermarket, you have a loyalty card, and every time you buy shopping you swipe your card, and so the supermarket can collect data about what you are buying. Now, if you are a massive supermarket, all this data is a lot, right? Imagine how busy your local supermarket is. Imagine that scaled up from the entire country. A lot of data is being collected every single hour, let alone week, let alone year. So a ton of data. I can't imagine a supermarket, a major chain, can analyze all of this data at once. So the big data is not really usable necessarily, but part of this data set will be. So if it's organized, you'll be able to separate it into smaller categories. So for example, maybe you are doing some analysis and you want to focus on people aged 25 in Manchester. So it's still not a tiny category, right? That's probably still hundreds, if not thousands of people, but it's much more manageable than the big data set. So really this in yellow would be classed as a small data set. So it's usable, it's still got some value to it, but we're more able to process it using normal methods. Effectively, we've got two data sets here, right? We've got a small one and we've got a big one. They are interacting because really the small one is part of the bigger one. Right, let's say we do some processing on our people aged 25 in Manchester data set, so all the data about what they have been buying. Do some analysis, have a look, and maybe you are thinking about chocolate if you're running a store, and you might find that two chocolate bars, Snickers and Mars, are quite popular with people aged 25 in Manchester, but for some reason dairy milk is not popular. And so if you are trying to sell more of dairy milk, you might add a special offer to dairy milk, reduce the price a bit to try and incentivize people to buy that product, not just the two most popular chocolate bars, right? So you're using a smaller data set, do some processing, some analysis, you find some trends, and you can apply it by changing your day-to-day business to try and maximize profit. Ideally, you look at the entire data for this, but that's just not possible because the data is too big. Okay, let's discuss some benefits and drawbacks, some advantages and disadvantages to using datasets, both big and small. So if we are able to analyze the dataset, so not really big data, which most talking about small data here, we can look for trends and patterns. So like my silly example about chocolate, we can look for a trend and we can make some decision based on this. So this step is also called data mining, if you come across this term, looking for patterns in data. Also, we showed the interaction between the big dataset and the small dataset. Similar datasets, so maybe the dataset for one shop can interact with a dataset from another, possibly to share data. So that is going to mean you don't have to collect as much data if you are able to import some data from another dataset. And because a dataset is not just data thrown together, it is organized in some way. Because of this organization, we can conduct searches on our data, so we can search for really specific data. So in my loyalty scheme example, I can search for data within a city, so Manchester. If it wasn't organized, I wouldn't be able to do that. However, as you grow your dataset, as it becomes bigger and bigger, the processing time, the analysis time, if you're doing data mining, that time is going to increase, eventually to a point where it's just not possible to do it on the entire dataset. At the point it becomes not possible, that's basically when it becomes big data. I said over here that having the interaction between similar datasets can be valuable because we can access more data. However, if you're not careful, this can lead to data duplication, where you have repeated data because you've combined two datasets which are too similar. Now, shared data is an issue if you're doing data mining, because you might have the same bit of data repeated 20 times, and so you might mistakenly think that is a trend when really it's just a mistake in your dataset. So your results won't be as good if you have duplication in your dataset. You can get rid of duplication, but this requires data cleaning. So cleaning being where you go through and delete any repeated bits of data. However, that would take time because it's effectively another processing step. And generally speaking, your analysis, if you're trying to find trends and patterns, that's all well and good. But if your actual data itself is not very good, maybe it's inaccurate, maybe there are errors, maybe it's old, maybe you haven't got much of it, you're going to really struggle to come up with anything insightful because your data itself is not very useful. And the term you may hear for this is garbage in, garbage out, or GIGO. The idea being if you put something which is of poor quality into your processing, the output, the analysis, is not going to produce anything useful either. So really the data collection step is the most important, because otherwise your analysis is going to be a waste of time.